Okay, so before we get into example 2, I want to just do a quick review of some things that we talked about already, but I want to make sure that we have it before we move on and people don't tell me they're confused or they're lost, they don't understand how to do this, blah, blah, blah. So first off, we said whenever we have a negative exponent, we must flip it to make it a positive exponent. Flip the base number, and this is our base right here. We must flip that base number to get a positive exponent. So we know it's 2 to the negative third is the original. So I'm going to rewrite this so it's 2 to the negative third over 1. And again, we're going to flip it to make it a positive exponent. We're going to raise the whole thing to the third power. All right, and then 1 gets the third, and then 2 gets to the third power, and so we get 1 over 8. Okay, so then what happens if we have a fraction that's there already, automatically starting off with a fraction, and we have to work it out again? So again, you must flip the fraction. Doesn't matter what the fraction is, you always flip it. So we flipped it, so 3 over 4, and that makes it a positive exponent. No matter what, if you flip it, it makes it a positive exponent. Flipping makes a positive exponent. Flipping the base number makes it a positive exponent. So make sure you write that down. Okay, so we flip it. So that's going to give us, if we do 3 to the third power, this is 4 to the third power. So that's 27 over 64. And that's it. And it's important that we remember that because we're getting ready to do that again with our flipping. But we're going to do this for example 2 now. And this is where we don't have just a whole number, we have a fraction to graph. So, hope everybody has that. If you don't, stop it and pause it and then come back to it. And that way we can go and write it down. If you need to repeat the video, go ahead and repeat that part of the video. This is important. Alright, so then we come to example 2. And this time I'm going to go a little bit faster, simply because we use the same information again. And we've already talked about flipping and everything. So we're going to graph f of x equals 1 over 2 to the x power. So 1/2 to the x power. And again, we follow the same process with the same x values. These x values do not change again. So nobody again should say they're confused or ask me, Mr. Hall, I don't know which one to use. Always use -3, -2, -1, 0, 1, 2, and 3. Every time. Every time. Not sometimes, but every time. Every time. Every time. Does everybody understand? Every time. Say it with me now. Every time. Just one more time. Every time. Use -3, -2, -1, 0, 1, 2, 3. Alright, so we go ahead and substitute all the numbers in. Let's substitute them in really fast. Fly through these things. And again, to make it a positive exponent, we flip it. So 1 over 2 flips to be just 2 to the third power. Flip this again, 2 to the second power. Flip it again, that's 2 to the first. Do we flip the other ones? No, because they're not negative exponents. So that's 1. So that's 1/2. That's 1 squared over 2 squared. And that's 1 cubed over 2 cubed. Right, so we get 8, we get 4, we get 1, 1 again. Sorry, my fault. That's 2 there, then 1, then 1/2, which I like to say 0.5. And that's 1 over 4, which we could say 0.25, so that's 25 cents. And then that is 1 over 8. And that one is 0.125. So if you think about example 1, that almost flips things around a little bit. Almost. It's a little bit different. Alright, so again, we have all this going on, and we're going to graph it out. And again, if this is going too fast for you, go back and stop it. Go ahead and review it and play the video all over again. It's okay. Playing videos over again is a good thing. So that way we know that you understand how to do everything. Because that's what's going to be on the final exam, that knowing that you know how to do the stuff, not me doing it for you. Oh, there's the bell. Alright, so again, we're going to graph this out. I'm going to go by twos. Go by twos. So 2, 4, 6, 8, and I'm going to go to 10. Just go to 10. And again, this is ever how you want to do it, but make sure that the increments match. If they don't match, then this is not going to work out. So don't just throw random numbers up there, because it's going to be wrong. Don't just throw numbers like 8, 4, 2, 1, 0.5, 0.25, and 0.125 on this y-axis, because it's going to be wrong. Just telling you that now so that you don't get upset with me later on when I say, nope, you got it wrong. Even though if you have all the beautiful work that goes there and you still get it wrong, that's bad. Don't do it. Alright, so we're going to plot all these points again. So -3, 8, -2, 4, -1, 2, 0, 1, 1.5, 2, 0.25, and 3, and 0.125. And something happens here, and hopefully you guys can see it after the fact. You might be able to see it now. What's going on? It's not a bad thing, it's actually a good thing. And again, when it comes to these smaller numbers that are less than 1, just make sure it gets lower and lower and lower for each one to show that it's getting closer and closer to the x-axis. And then we go ahead and connect them. Excellent! Yay! And the only other thing that we need to make sure we have is our handy dandy super duper asymptotes. Asymptotes. Dun, dun, dun. Make sure you have that asymptote there, because if you don't have the asymptote, it's going to be wrong. So a lot of stuff that has to be here, because we have to attend to precision. And precision is important. Alright, so that is our graph. So not hard. We got this. We can do it. So you should be, at this point, you should be able to do a fraction. You should be able to do a whole number. And if you don't, again, call me over. Call me over. Alright, and I'm getting ready to post a video of the practice problem. Alright, have fun.